Good morning, girls. Today we are going to discuss about relational database integrity. So, actually, we have discussed what a database is, what is data, and all other things of the first chapter. As they are finished, and directly moving on to this topic, database integrity. So, what does database integrity define? Actually, it refers to the accuracy and consistency of data stored in a database. So, what do you mean by accuracy? Accuracy means correct. Consistency means maintaining the same data all through the database wherever that data is going to be referred. Okay, so um, we have to maintain database integrity to enforce that the database or to maintain or to make the database to work properly. See, for example, how the database integrity is compromised or disturbed. See, when a user accidentally tries to enter a phone number into a date field, this will disturb the integrity of the database. So, to stop the user, to prevent the user from making such type of mistakes, we will be enforcing database integrity through some constraints that we will be discussing in the next class. As of today, we are going to discuss more about keys because yeah. So before we moving on to keys, let's see what are business rules. So what are business rules? Business rules specify conditions and relationships that must always be true or must always be false. So to enforce data integrity, you have to follow these business rules. You have to try to satisfy these rules. So automatically the integrity is maintained. So what are the uses of this data integrity? It ensures recoverability, searchability, and it is uh, helps in the stability of the database and as well as reusability and helps in improving the maintenance. Okay, next. So, what are keys? See, actually, what is a key? Keys in DBMS is an attribute or set of attributes which helps us to identify a row or tuple in a relation, otherwise called as a table. So already we have discussed in the class. So a key is can be a single attribute or a set of attributes. Why I am saying here set of attributes means sometimes you may not be able to identify a single attribute. Then in such conditions you have to use a set of attributes to identify it. Um, What are the uses of the keys? They allow us to find the relation between two tables. For example, primary key and foreign key. They establish the relation between the two tables. Next, keys help us to uniquely identify a row in a table by a combination of one or more columns in that table. Already I have said you, it can be single attribute or set of attributes. Key is also helpful for finding a unique record or row in a table. Yes. What is the main objective of key? It is to find a unique record. I mean, the unique, what does it mean? One and only. So there should exist only one row for that one particular key value. If multiple rows exist, then the definition of the key itself gets compromised. Next. The different types of keys being DBMS or your database, whatever you call, primary key. So what is primary key? It can uniquely identify any data row of the table. So a primary key is nothing but it is used to uniquely identify a row of a table. The thing is, this primary key is selected from one of the candidate keys and becomes the identifying key of a table. So to search or to identify a tuple in a relation, the first and foremost thing that you need is a primary key, which is always unique. Then only it can identify a data row of a table uniquely. Clear? Next, super key. Super key is a superset of primary key. That means superset in the sense it can contain other keys as well. See, the super key contains a set of attributes including the primary key, which can uniquely identify any data. So primary definition of a key is to uniquely identify a row in a table. So whether it is a primary key, super key, candidate key, whatever it is, it has to uniquely identify a row in a table. So listen carefully, be thorough with these concepts, because the next topic after this integrity constraints, the next topic that we are going to discuss is normalization, and these keys will be very much important in that particular topic. Super key. So super key is the superset of primary key. Also, a super key may have additional attributes that are not needed for unique identification. So we already, as we said, a super key is a set of keys which contains the primary key. So other than primary key, it may contain other keys also. Other attributes also that are not needed for unique identification. Next, candidate key. See, the candidate keys in a table are defined as a set of keys that is memorable and can uniquely identify any data row in a table. So, then all the attributes in a table can be divided into different sets of candidate keys. See, a table can have multiple candidate keys, but only a single primary key. See here, a table can have multiple candidate keys, but only a single primary key. So by grouping together the keys, you can form multiple candidate keys. But out of those keys, you have to select one key as primary key. See, the primary key should be selected from the candidates. Every table must have at least a single candidate. That candidate key is nothing but primary. If you have one and only one key existing, that key is primary key, and automatically it is a candidate key, because primary keys should be selected from candidate keys. And one more thing that you have to remember is a table can have multiple candidate keys, but only a single primary key. Next, composite key. What is composite key? If any single attribute of a table is not capable of being the key, that is, it cannot identify a row uniquely, then we combine two or more attributes to form a key. This is known as a composite key. Say, for example, if I don't have employee ID or student ID, let's imagine like that. Or if you don't have that, you have only employee name as an attribute in your table. You can't use employee name as primary, because there can be people existing with the same. So what we have to do then in such situations, you have to use a combination of keys. That means you have to use more than one key. You have to use two keys or three keys combined together to uniquely identify a row in a relation. So such type of key is called composite key. Next, here you can use your phone number along with name as a composite, because this phone numbers cannot be overlapping. They cannot be duplicated unless and until they they both belong to the same family or same household. But then their names will be different. So you can use student name and phone number together as a combination of composite key to identify a row in it. So secondary. So what is secondary? See, only we said there are there can be multiple candidate keys in a table. See, there are multiple candidate keys in a for a table for a relation. So then in that multiple candidate keys, only one key can be selected as a primary key. So the rest of them are called secondary keys. Okay. Next, foreign key. A foreign key is an attribute in a table that acts as the primary key in another. So a foreign key is nothing but an attribute in one table, which is nothing but a primary key in the other table. What is the use of this foreign key? It is useful in linking together two different tables. So you can't directly join the tables through links like in lines to them. You have to maintain a common column in these two tables in order to maintain in order to link these two tables together. And one thing we have to specify here is the data that should be entered in the foreign key column should be done with great care, because wrongly entered data can invalidate the relationship between the, it can destroy, it can uh, cut off the relationship between the two tables if you don't maintain the data accurately in these two tables. The accuracy means the values which exist here in the primary key should be the same in the foreign. So this is about your foreign keys, all together about your keys. So see, for example, here I am defining a student table. Here I am taking four attributes or columns: student number, student name, um, student phone number, and subject number. Here I'm not specifying the subject name here. I'm just specifying only the subject number, because for different courses you have different subjects, and it is to show the foreign key here. I am creating two different tables. One student table and the other one is the subject table. Okay, there you can maintain. See, I will show you the difference. Student number, here student is the prefix, because to tell that you are maintaining, you are defining a student, you are prefixing it with the column name with student. See here, it is a subject table, so here I am prefixing it with subject. Subject number, subject name, and subject instruct. See here. Why I have maintained subject number here is I am maintaining subject as a different table. I'm not including the subject name here in the student table, because if I maintain a subject table, I can maintain here the instructor name separately. If I combine these two tables together into one, it is not relevant to have the subject instructor name in the student table. Yes, student table should contain the details only related to student, not the names of the teachers or lecturers or instructors who is teaching that particular subject. So that is the reason I am maintaining two different. Next, enroll table. So here I am maintaining another table called enroll table, which contains only the student number and the subject number. So which, if you know the student number, you can directly link it to the student table or subject table. Any one of those. No need to link both of them. If you want to know about the subject, you will go to the subject table. If you want to know about the student, you will go to the student. So this is about your tables. This is how your tables look like and the data in the tables. See, here I'm specifying. Here I'm specifying how the super keys are taken from the student table. See, here you have what are the column names here: student number, student name, student phone number, subject number. These are the attribute names in the student table. So what are the super keys for the student table? You can take only student number as a super key, only student phone number as super key, student number, student name as super key, Student number, student phone number as super key. Student number, student name, student phone. Say combinations like sets. Say if you have 1, 2, 3, 4, 5, a set contains these numbers 1, 2, 3, 4, 5. The subsets, what are the subsets of that particular set? 1, 2, 3, 4, 5. 1, 2, 2, 3, 3, 4, 3, 5, like that. So, in the same way, you can generate n number of super keys from a table. So, these are super keys for the student table. Next, the candidate key in student table is student number or student phone number. So your student number or student phone number is taken as the candidate key here because we have put a condition that always, I mean, these two are not the only candidate keys. You can create multiple candidate keys, but if we have said that a primary key should be selected from a candidate key, and what is the condition of the primary key? It should uniquely identify a row in a relation. So the primary key in the student table is student number. Student number. Why? Because if I take student subject number as the primary key, what happens? It can't be taken as primary key. Why? Because here number 10 is repeating in two rows, which is not unique. It's getting repeated. So what is the definition of a primary key? It has to uniquely identify a row in a relation. So the primary key in the subject table is subject number. The primary key in enroll table is a combination of subject number and student number because and only through subject number you can't identify a row in an enroll table or only through student number you can't. So the reason here you're using both of them together in a primary as a primary key. Already we have discussed. See when uh, composite key we have discussed that if a single attribute is not sufficient to identify, then we can use a set of attributes, combination of two or more attributes. So the example for composite key, this is an example for your composite key because we are using two attributes together to identify a row in a table. Next, secondary key in student table is your student phone number and one more secondary key is student name and student instructor. Here I am not including phone number. I am taking only student name and subject name and subject instructor as secondary key in the subject table. Next, subject number is a foreign key of student table and primary key of subject table. See here, see subject number is the primary key in this table. See, this is the primary key because through this a subject number only you can identify the subject name and the instructor name. But this is not the primary key in the student table. It is just another table in the student table. So here that is what. See, subject number is a foreign key of student table and primary key of subject table. So in the student table, it is called as foreign key and in the subject table, it is called as primary. Okay. So this is about your keys. So if you are thorough with these keys, if you understand these keys, we can continue tomorrow to the next topic, types of integrity and that too. There are four types of integrity actually, but we will what according to the syllabus we need to discuss only two types of integrity. One is referential integrity or relational database referential integrity, and the other one is entity. So if you have any doubts, Please mention them in the comment section or in the WhatsApp group. We will discuss about them in the. Thank you.